Now I introduce the independent and identical distributed random variables. In machine learning, a model is trained by using a training dataset, and the trained model can be generalized to a new sample that never appear in the training dataset. That means the trained model can use the new sample as the input and generate the correct result. For this purpose, a training dataset should be independent and identical distribution. Independent identical distributed sample has two meanings. One is identical distributed, that means all the samples in the dataset are taken from the same probability distribution. That means all the samples have the same probability distribution. Second, the property is independent. Independent, that means all the samples in the training dataset are not correct each other in any way. That means they are independent. In addition, independent and identical distributed training dataset make the model simpler. For example, you calculate the join probability of two samples. By using the I.i.d property, we can calculate each probability distribution for a sample, and then we multiply their result. And I.i.d training dataset also can make the result more interpretable. Interpretable, that means since we know the training dataset are I.i.d, so we know results of the meaning exactly. Informally, we suppose two random variables x and y, and define their cumulative distribution function of x, fx and fy. So the two random variables x and y are identically distributed if only if the two cumulative distribution functions are same. Two random variable x and y are independent if only if the joint cumulative distribution function are equal to the multiplication of each cumulative distribution function. We say two variables x and y are I.i.d, means they are identically distributed and independent. For example, let's say for the identically, that means we sample item x from the training dataset. We have the same probability with we sample the item y from the same training dataset. That's the identically distributed property. For the independent property, that means we need, for example, we need to calculate the joint probability for sample item x and item y. Using the I.i.d, using the independent property, that means we can calculate the cumulative distribution for y and x. Then we calculate the multiplication of each probability for random variable or samples from samples x and y. In addition, there are two terminologies. One is without replacement. That means after we sample this sample x, we will never put these samples back to the training dataset. With replacement, that means after we sample this item from the training dataset, when we sample the next, before we sample next samples, we will put x back to the training data set. For more details, please check with this reference. Thank you. Bye.